It's working! Hello everyone. In this video I will be showing you how to make a wind speed meter using this anemometer and an Arduino Uno. Now this video was originally supposed to be about making a solar tracker phone charger, but as you can see, my 3D printer here decided to kick the bucket and is no longer in commission. So likely my next video will be how to assemble an ANET A8 3D printer. So stick around for that video. Just to give you a quick preview, I did start working on my solar tracker project. However, this 3D printer going kaput has put a damper on it. So please subscribe if you're interested in this video. It should be a lot of fun, and once I have my 3D printer back, I'll be able to continue working on this project. For this Windspeed project, I'll be using an Arduino Uno and a 16:2 LCD display. I purchased this anemometer on eBay, and it came with 5 blades, I guess one extra in case one breaks. The enclosure is sealed, so it looks like this is completely waterproof, so it could be mounted on a roof of a shed or an outbuilding. And comes with a pretty long cord. I'm going to guess it's about 1 meter long. This wind anemometer cost me about $10 on eBay. I'll be sure to leave a link in the description. Now this anemometer is basically a DC generator. The red wire is positive and the yellow negative. So I'm going to hit it with a little dust off, get this thing spinning a little bit, and watch the speed change the voltage. Okay, let's talk about setup with the Arduino, which is going to be very simple for this project. First, let's set up the LCD screen. And this LCD screen, I'm using the I2C backpack. As you can see, makes the hookup quite a bit simpler. So I've connected ground to the ground pin on the Arduino, VCC to the 5-volt pin, SDA is going to analog 4, and SCL is going to analog 5. As far as the anemometer, I have the yellow wire connected to ground and the red wire connected to analog 0. Okay, so the anemometer produces a voltage, but what does that voltage mean? Well, fortunately, the seller on eBay listed the wind speeds in meters per second and the corresponding voltage output from the anemometer. Now I am interested in my wind speed in miles per hour, so I did a little conversion in Microsoft Excel, but if you want to stick with meters per second, that is fine. Anyway, here are the voltages that correspond with various speeds. As you can see, it peaks out about 2.5 volts, 73 miles per hour. Now, whereas this device gives a voltage output, we will want to use an analog read command on the Arduino. Analog read will produce a value between 0, corresponding to 0 volts, and 1023, corresponding to 5 volts. Now, that is based on if we are using 5-volt logic on the Arduino. So if we were to read a wind speed of 73 miles per hour, we would expect an analog value of 512. Now, if we desire finer resolution, there's a few things we can do. For example, we can jumper the 3.3 volt logic pin on the Arduino to the analog reference pin, and that will stretch out the range of values so that at 73 miles an hour we would expect an analog value of 774. Now, if we want to get really crazy, we could use an analog value of 2.5 volts. Could use a voltage divider to split the 5 volts on the Arduino in half, and that would give us the full range of values: 1023 corresponding with 73 miles per hour. Now for this example, I'm going to keep it simple. I'm going to stick with the default 5-volt logic on the Arduino, and let's see what happens. Now if we plot the analog values here along the x-axis against the wind speed on the y-axis, we can see that the points are pretty linear, and therefore we can derive an equation to use in our Arduino code to interpret analog values and translate them into wind speeds. So here are the equations you'd use in your Arduino code. We're going to use speed is equal to the analog read value times our maximum speed of 73 miles per hour divided by our maximum analog value of 512. Now if you're using 3.3 volts or 2.5 volts, you'll want to adjust the denominator accordingly. And if you're going to use meters per second instead of miles per hour, you would put 32.6 in the place of 73. Let's jump into the Arduino IDE and write some code. Okay, the first thing I want to do is write some notes to remind us how to connect the LCD to the Arduino and how to connect the anemometer to the Arduino as well. So we'll connect ground to ground, VCC to 5 volts, SDA to analog 4, and SCL to analog 5. We'll also connect anemometer, if I can spell it right, red wire to analog 0 and yellow to ground. Okay, now I want to include the libraries that are needed to run the LCD screen. We're going to need wire.h, lcd.h, and we're going to include liquid, crystal, I squared C dot H, and define our backlight pin as 3, and we're going to configure our display . This is the hex code for my display. And the configuration string for setting up the display. Now I'm not going to go into detail on this because there are several other tutorials out there on how to use this type of LCD screen. Now the next thing I want to do is define a variable, and I'm going to use a float so that we can have decimal places. We will call this variable Windspeed and initialize it to 0.00. Now in our setup loop, we will start up the display with the LCD begin command, and we have to tell it what size of screen we're using, so 16 by 2. We'll set our backlight pin, which is defined as 3 to positive. And we'll turn the backlight on. And we'll send it home. set our cursor position to 0, 0 on the LCD display, and we will write our first command here. Windspeed in miles per hour. So that will display on the top line of the LCD. We'll also need to set the pin mode for analog 0 as an input, as we'll be reading our values from the anemometer. Now for the main loop, we're going to start by calculating our wind speed. And we're going to use the equation that was developed in our Excel spreadsheet. I can type here. And use the analog read value of pin A0, and we're going to multiply it by 73.0. Since we're using float, we want to use a decimal place. And we're going to divide that by 512.0. Close our bracket. And then we're going to set our cursor position to the second row. And what we want to do here is just clear out any previous values. It's a good way to erase previous values. And we will reset our cursor position back to the first column of the second row. And we'll print our wind speed value. And just for fun, let's put a half-second delay, 500 milliseconds, so that the display doesn't refresh too often. Okay, let's upload this code and test it out. Okay, let's power this thing up and see what happens. Here I'm going to hit it with some dust off and get this thing spinning again. As you can see, it seems to be tracking pretty well. Okay, so we're clearly getting readings, but how do we know that these readings are accurate at all? We need to test to make sure that this is reading accurately, and I've got an idea for that. Okay folks, here's how we're going to see if this thing is working. I've got the anemometer frog taped to the hood of my car, and the cable is a lot longer than I thought originally, probably 3 meters instead of 1. Got it leading up to the Arduino and the display here on the dashboard. So let's hop in and see if it works. Okay, let's do a little speed test here and see how close we are. Looks like it doesn't start to spin until about 5 miles an hour. Right now I'm going about 21 miles an hour. Looks like it's tracking pretty close. Let's speed up a little bit. Okay, now I am about 29 miles an hour, and it's showing about 29 on the gauge, so that's pretty close. Slowing down to about 20. Alright, now I'm showing about 30 miles an hour. The gauge is showing 28, 29. So it's tracking pretty close. I'm pretty pleased with this. Well, I hope you found this video useful in your personal projects. If you did, do me a favor and give me a like and subscribe to my channel for more content like this in the future. Look what I got in the mail today.